Can you see my screen?
Loading.
There we go.
Awesome.
Yep.
Yeah. Awesome. Welcome, everyone. This is our second coding challenge. Our community is Deep Learning Adventures, and if this is your first time, we've been engaging in a 5-week coding challenge using TensorFlow to tackle different AI and ML challenges, including computer vision, natural language processing, time series forecasting, and dealing with structured data. My name is George, and I'm joined by my great friends and co-organizers today, Robert and David. And I just want to give a quick overview of our meetup and our community so that if this is your first time, you feel welcomed, and hopefully you can join us in our next session. So if you found us through Meetup, the link again is Deep Learning Adventures, the name of the Meetup group. If you found us through Crosspost or several other meetups, thanks again for joining. We have a Slack channel as well on the very Meetup page. We have a GitHub repository as well. And all our sessions are recorded and uploaded on YouTube the next day. For the last 2 or 3 months, we covered TensorFlow in detail, TensorFlow in practice from a developer perspective. That's a specialization in Coursera that we took. That prepared us very well for the TensorFlow developer exam that several of us took and passed. And for the last week, and this is the second week, we've been delving more from a software developer perspective, more of a hands-on perspective. How can we use TensorFlow to tackle different challenges? So some of the meetups that I've cross-posted, I just want to say thank you to the Bethesda AI meetup, as well as the Data Education DC, Upskill ML, as well as the Machine Learning Paper Club. Had a great session yesterday. We won't have much time, unfortunately, to go through the introductions. We went to that last time, but if you're new, welcome again, and hopefully we'll get to do this introduction session another time. Just some attributions that some of the content used to come from Coursera and Deep Learning. Some of it might still be in these slides. I just want to pay attribution to Coursera and Deep Learning for providing us with great content. And if you've heard of TensorFlow, or if you've never heard of it, it's an end-to-end open source machine learning platform. You can tackle simple regression problems or computer vision problems, as well as natural language processing problems in your day-to-day tasks. In terms of setup, some of you joined us earlier and you could hear discussion about GPUs and all that. Most of us have been using Colab, which is basically a free Jupyter notebook hosted on Google Cloud. You don't need any powerful machine to access it. You just need a browser and a decent internet connectivity. Everything runs on Google Cloud for free for you, and you get up to 12 hours of uninterrupted connectivity to CPU, GPU, as well as TPU for more advanced applications. So last week, we covered the computer vision challenge. We tried using computer vision and convolutional neural networks to detect diseases in a cassava plant. And this is a challenge that many farmers, especially in the sub-Saharan African region, face. Today, we'll take a little bit of a different approach. We'll look at Corpus from the popular TV show, The Big Bang Theory. And the goal really is to get us familiar with text and emotions and how we as humans classify or detect emotions from video, from audio, as well as text. And we'll see what are the challenges with just using one media, one source of that, which is text. Next week, and I'm hoping week 2 would serve as a preliminary as well as a preparatory session for week 3, which is using a much larger, well-annotated data set for another popular TV show called Friends. We'll be using different NLP techniques there, including sequence models to detect emotions from text. Then in week 4, we'll talk about structured data set. We'll look at credit card transactions. We'll be looking, I think, at 250,000 transactions from a Kaggle data set, and we'll be using different approaches to detect them. And we'll finish this 5-week challenge with a time series prediction challenge, predicting weather data from a trade using classical ML as well as deep learning approaches. The slides will have all coding session, all coding challenges. I won't go through the details of challenge 1. We also have a recording on our YouTube channel. Feel free to check it out. But we went through this interesting challenge. We're very active on Slack as well, especially on the coding sub channel, where Robert, David, and I posted our notebooks as well, and we are looking at this disease classification challenge. Cool. Any questions so far about last week, or what is the goal? What are we trying to do, and things like that? I just want to open it to anyone. David, Robert, any comments from you? Can you hear me, David, Robert?
Yeah, I don't have any further follow-up.
Okay.
Invite you to look into the coding sub-channel to see kind of our thought process and our results and some of the issues we came across that were very interesting. So
yeah, I just went in and looked in the coding sub-channel and saw that it's way more discussion there than it was the last time I looked.
It's been a busy 2 weeks, I would say. Cool. All right. Let's start with week 2, challenge number 2, and let's set the background a little bit. So we are inspired for challenge 2 by a SocialNLP challenge called EmotionX 2019. It was an online challenge where, given a rich corpus of the Friends TV show, as well as from Facebook messaging text, the goal was trying to predict emotions. And there's a paper here that I will refer to, but basically the goal was, you have, let's start with the Friends data set, which we'll see next week. They uploaded it on Amazon Turk. They used 5 annotators for each sentence, for each record, and they annotated into one of several emotions, including neutral, joy, sadness, anger, disgust, and I think another one. We'll look at it in detail. But this was a very interesting challenge, and it really inspired me to take a closer look at the corpus that they covered, but also maybe us as a community could start annotating a very simple, a very small corpus, so that later on, hopefully, we can use for our own emotion detection. So I'll just share my screen here and look at the challenge here. So the original challenge, I think, had only 4 different categories: joy, sadness, anger, and neutral. And later on, they added a few more. And then the data sets, there were 2 different data sets. One was the Friends and the emotion push. The emotion push was basically recording chat messages from Facebook, asking for permission, of course, for research from the different users. And the way that it was annotated was, you have a speaker, in this case from the TV show, the character named Chandler, the dialogue or the utterance, might do this, all right, and the emotion, surprise. This is based on the video and audio aspect of it. And the annotators, they had there are seven different categories or different emotions, and there's 5 annotators. So the sum of this annotation label here will always be 5, and you can see how the different annotators could be split between one or another different category.
So that's their votes?
Yeah.
And emotion was the most common one, so 0 was, I guess, emotion was surprise.
No, it looks like the order of the emotions in the string, if you look down below, is neutral, joy, sadness, fear, anger, surprise, disgust. So neutral and surprise are the 2 that get votes. That's how I interpret it.
Yeah.
Oh.
Yeah, so 2 people voted it as neutral and 3 people voted it as anger.
What's the emotion category? I mean, the emotion tag there, then is that considered the ground truth or something? Or?
Yeah. So that's actually a layer. Sorry. The you mind muting yourselves? I'm trying to. There you go, Dimitri. If you don't mind, I'll mute you. So there are actually two layers or two tags in this data set. There's an emotion and an annotation. There's actually a screenshot that I think is more useful. Let me share it here.
The other reason I ask is because it said right below there, it said the emotion is calculated based on the annotation.
Yeah, that's what I was wondering too. It looks like the emotion isn't really a unique bit of data. It's just calculated from the other one.
Right.
So there are two versions of this data set. The first one only had the emotion, I would say. And the second version of it added another layer called sentiment, if this is positive, neutral, or negative. Let's go back. Yeah. So this looks like the first version of it, where you just have the emotion and the annotation. Let's look at the annotation. So yeah. So for example, the above line denotes that 2 annotators voted for neutral and 3 voted for surprise. The sum is always 5. And the emotion string is the utterance label. It's calculated from the annotation as follows. Oh, I'm sorry, I forgot about this. This is based on majority vote. So if the majority vote is, let's say, 3, which is anger or surprise in this case, second to last, then the overall majority is surprise. The overall emotion is surprise. So that's the majority vote. The emotion is the majority vote. The annotation is individual votes or annotations from different users.
So it only counts if it gets 3 votes or more. If it's split more than 2 ways, it could end up just becoming labeled non-neutral.
Yes. So let's say if it's 1, 1, 1, 1, 5 ones, then yeah, there's no majority vote. Everybody thinks it's something else, and it's non-neutral in that case.
By the way, I remember this episode.
It's a funny one.
You can tell that just from that one line there?
Yep.
Oh, there was another augmented data where basically what they did is they took the English utterance, they translated it to German, and then translated it back to English. And this is the back-to-back translation. You know, when you do this, sometimes you lose the underlying concepts. So in this case, it was a great night. When you translate it to French and back to English, it was an incredible night. And when you translate it to Italian and back to English, it was a fantastic night. I'm not sure if they used this augmented data set, but it's interesting to me if the core concept or the core emotions is preserved when you go from one language to another and then back to the original language. And just to get an idea of the entire data set, let me zoom in a little bit more. So this is another scene or another dialogue. The speaker is Chandler, and he's basically applying for a new job, and he's saying, also, I was a point person on my company's transition from a KL5 to GR6 system. You know what that means. And the annotators decided this is neutral. Most of them, 4 of them. One decided 1, which is
Joy, I think.
joy. Yeah. Then the interviewer says, you must have had your hands full. All of them decided neutral. Channel that I did neutral. Neutral. Let's go to this one. My duties. All right, that's surprise. The majority is surprise. And so forth. It's an interesting data set, right? So based on just the utterance, the challenge is to identify the emotion. So that will be our labels for our classification or detection task next week. This week, we will look at a scene from another TV show, and our goal is to basically build this emotion label for a very simple scene. That's the goal for this week. Any questions about this data set or how it was constructed and what is the label and its meaning.
That was a great data set.
Yeah, it has 2,000 dialogues and about 30,000 utterances, basically sentences. So we're good in terms of.
The training data will be just the speaker and the utterance as shown there?
Yes, yes. Just the speaker and the utterance. And for training, we'll use emotion as a label. And for test, for validation as test, we also have label data. So there's non-label data here. And the goal is to predict emotion as accurately as possible. Cool. So I have the links in our meetup as well as on the slide. Let's go back to our slides. So that was the SocialNLP EmotionX 2019 challenge. And the EmotionLines was just a Friends corpus. And this is some examples here. Speaker utterance emotion, speaker utterance emotion. This is Joey here. He needed a shirt. He's built something on a shirt. And this is from the Amazon Church perspective, how the UI looked like for them to score. So they had the different options, and you're supposed to read the conversation and then just score it with one of these tables. And that's the same example that we saw before. Cool. So for this week, we'll look at another TV show, The Big Bang Theory, and we'll look at season 4, episode 7, and we'll annotate. There's about 60 or 70 lines that I put together. I could do this for more, but I just wanted to get our hands dirty with this approach and see how we'll handle it. But I have a spreadsheet. If you don't mind clicking on the spreadsheet right now, it's on the meetup page as well as on the slides. You should see a Google Doc spreadsheet. And when you open it, you can do that now. Let me see how it looks. Let me share my screen so you can see how it looks like. I see somebody joined. One. Yeah, go ahead. The more the better. At least 3 or 5 people will be interesting to join. So let me show you again where this is. This is on our meetup page, Deep Learning Adventures. And this is under step 2. Under step 2, I'll put it also on Zoom right now. There you go.
How do we rate scene?
I don't think you can rate scene. It's a good question though. Okay. So I think in the paper, with the way they did it, or the Amazon Turk, they just did it from text. We can do it from text. I think it's more interesting, more challenging if we actually do it from the video itself as well as the text. It's a short clip. It's about a few minutes long. So what I will do is, first of all, I want to make sure that you're familiar with the layout. So there's a speaker, there's a dialogue, and there are different labels that I'm asking for all of us to increase based on if they think this dialogue belongs to the neutral label or the joy label or the sadness, fear, anger, surprise, disgust. This laughter label, I added it. It's interesting. I think I haven't seen it before, so it might be cool to play with. Okay, so actually I'm going to play the scene, and I will pause it every now and then just to give you an idea, just to give you some time to catch up. But we'll start with a scene which is basically in the apartment, and there are 2 characters, Sheldon and Leonard, and one of their friends is actually trying to get an FBI clearance for a space project, and the FBI agent is asking them some questions about their friend. But just to give you some context. And if you can see my screen, you can increase your volume. I'll play the scene, and I will pause it after a few, after the first sentence, so I give you an idea of how would you score it?
I get that? Not particularly.
Maybe that's interesting. That laughter level, not particularly, is pretty high. So I'll label that for us. I'll just do a 3, from 1 to 3, let's say. So want to get that? I don't know what that is. Neutral, maybe. Not particularly. Sadness, fear, anger, surprise, disgust. Maybe neutral. Okay, let's continue.
I suppose I could if I were asked.
Okay, could you get that? I suppose I could if I was asked. Maybe. Let's continue.
Get that.
So would you please get that? You could see that he's a little bit annoyed at Sheldon. So I don't know, we don't have an annoyed. Maybe anger, yeah, that's what I would say. Label.
Of course. Why do you have to make things so complicated?
Of course, why do you have to make things so complicated? To me, that's a little bit sarcasm, but if you know the show and if you know Sheldon, he has a hard time detecting sarcasm. Okay, so complicated is also 3. That's a very high laughter.
Dr. Cooper,
Yes?
I'm Special Agent Page, FBI.
You say you're Special Agent Page, FBI.
Here's my ID.
It's a very funny scene. And here's my ID, and here's my Justice League membership card. That's definitely a 3. Cool. I love the different annotations going on here.
So just to clarify the task here, we're not adjusting the laughter levels. We're just voting in the other bit.
Yeah. Any of the colored ones. Yeah.
But how do we vote? Do we put in a 1, or you're putting 3s in some of these? How does that work?
I would say if you see a number, increase it by 1. Yeah, sorry, I should have said in the beginning. If you see a number, just increase it by 1.
Okay.
The 3s could be 1s as well. It doesn't really matter.
Okay. So each one is 1 vote each time we put. Yeah. Okay. Great. And just do our own addition. Got it.
For example, if I see a 1 and I also think it's neutral, I'll add a 2 there.
Okay. Thank you.
Yep. Good question. Any other questions before we continue? Okay. So we are row 14. It's my Justice League membership card.
But that doesn't prove I know Batman.
I just want to ask you a few questions about Howard Wolowitz.
Oh, about right. I doubt.
Okay. I just want to ask you a few questions about Howard Wolowitz. So we're in row 15. Perfect. So he's asking her a question. He's basically challenging her, are you actually FBI? And I don't know if there's an emotion for that. Surprise, maybe? Maybe.
It's odd that there's not one here for finding something funny, or
Funny, right?
laughter, I guess would be it.
Yeah.
Not the general, audience laughter level, but somebody, just finding something funny.
So yeah, I mean the laughter level kind of captures that, but maybe not fully, right, Anne?
Yeah. Okay.
Fidelity, bravery, integrity.
Correct, now to business. 18 years ago, I sent the FBI crime lab samples from a bag of excrement that had been lit on fire on my front porch for fingerprinting and DNA analysis. Why haven't I heard back yet?
The FBI crime lab does have a lot on its plate.
Okay. The FBI does have a lot of this. Yeah. I feel sometimes these 5 emotions are not enough to express what is going on here. Well, when Sheldon was asking the question, he was clearly sad or unsatisfied, maybe anger or disgust. I'm not sure. Yeah.
Well, that's of little comfort to a nation attempting to scrape burning feces off its shoes.
Would you mind if we talked about Mr. Wallowitz now?
A little, but go on.
Thank you. Would you characterize him as responsible?
Okay, so she's posing a question now. She's actually interviewing him about his friend for his background. Would you characterize him as responsible? Row 25.
I'm going to answer that with a visual aid. This is my 9-disc complete Lord of the Rings trilogy Blu-ray set. Mr. Wallowitz borrowed it. Damaged plastic retention hub number 3.
That is funny. Get a lot of neutral there. Surprise, maybe. Would you characterize that as responsible?
It's fun because Sheldon's version of anger is different than everyone else's.
That is true. That is true. But we are annotating it, not Sheldon. So.
That's really not the sort of thing we're interested in.
You heard me say Blu-ray, right?
I did.
Very well. Would you be interested in knowing that Mr. Wallowitz once snuck onto my World of Warcraft account and changed the name of a certain level 80 warlock from Sheldor to Smeldor?
Okay, so maybe a little bit discussed there. Row 30. Sheldor to Smeldor. Yeah, I think so.
I'm afraid not. Is there
A lot of content there. So I don't know if assigning one label to this 3-sentence does any justice at all, especially the Mars rover incident. Yep, surprise, anger. I agree with you.
Boy, it seems so subjective, doesn't it?
It is. It is. That's the tricky part, right? I mean, us as humans, we cannot agree on an absolute number. So imagine building a model that can predict these emotions.
If that's not irresponsible, I don't know what is.
the Mars rover?
Okay, he's blinking there. That's, if you know Sheldon, that means he's in trouble and he doesn't know how to respond. So the Mars rover, definitely surprised there, yep. I'm wondering if the model will pick up the question mark and just tag anything with a question mark as surprise in our deep learning model next week.
Yeah, that would be.
Yeah, it'll be interesting to see, right?
Did I say Mars rover?
You did.
That was actually a poorly chosen example, as it had nothing to do with me.
It was a pretty poorly chosen example.
I think there's a bit of bias with us all doing it together, though.
Oh, because you see others and how they're annotating it?
Great point.
There's some...
You know, the other thing that makes it hard, George, is this is a comedy. So things that on their face might look like anger are really that sort, you know, there's a huge laugh track underneath. So you're not supposed to take it as the guy's actually angry, you know, the laugh level undercuts it somewhat. So it's hard with this set of sadness, fear, anger, because all of those things could be being expressed in a humorous way.
Yeah.
Well, the other thing that I think is going to make this task especially challenging is the fact that the humor and emotions, basically the entire gamut of emotions, are so dependent upon the context and not necessarily determined just by the few words that you see in one line, right? When we're trying to predict on this, we're not going to have access to the previous sentences, right? We're just going to get the single line.
Yeah.
But that's the classic challenge in machine learning anyways, right? Contextual.
You'll actually get access to the entire sequence. Sorry, Robert. So you will get access if you want historical information. You can go back and look at it.
Oh, they won't be fed as individual examples.
And the training set, if you look at the training set, it's actually part of a dialogue. So it's coherent and consistent. So it's not that each sentence it's from a different completely scene. So there's a scene, and within the scene, there are different dialogues. So Chandler interviews, Chandler interviewer. So there's a flow. And then you'll see there's a second scene here. Let me scroll down.
So the idea is that you could use one recurrent neural network to predict them all simultaneously.
Exactly. Yeah. So then if you see here, this is a list. So the second item is a completely different scene. I don't know what scene it is. It doesn't have a scene name. It says, hey, Mon, hi, you want to hear something that sucks? Yep. Chris says they're closing down the bar, blah, blah, blah. And then let's look at the third one. Like, Rachel, hi, what are you doing here? You know, this building is in my paper route. Then another one. So within, I don't know how many there are, though. It could be a variable length, right? So for us, it's a sentence. Actually, it's not more, it's more than a sentence. It's a variable length dialogue. Could have, 10 sentences. You could have 20 sentences. You can have 3 sentences, and each sentence has an emotion tagged to it.
George, I was just thinking you were smart to put in the laughter level because, talking about this being humorous, and I know we're just doing this not to drill down too deeply, but it's kind of like from the speaker. Is it from the speaker's perspective or from the hearer's perspective? And, the speaker may be feigning anger. That's his character, saying he's angry about, I don't know, some of those game things he talked about. But as the hearer, because of the laugh track, you're cued that he's not really angry.
Yep, exactly, yeah.
It's funny. It's not real sincere anger. So it's got a couple of complex layers, but it does give you an idea of how wrong these engines could then start to be.
Mm-hmm. Yeah, to me, the laughter level is almost from like a receiver's perspective, like almost baseline.
Yeah. But without that, you get a totally wrong impression of the scene as played as a comedy.
Yeah.
It would seem like a very anger-filled scene, and it's not.
Correct. Cool. Okay, 3 more sentences, and we're done.
Yes, well, let's talk about it anyway.
I don't want to. Not that my disinclination to discuss the topic should be interpreted as evidence of Howard Wolowitz's culpability.
Cool. So basically, Sheldon can't keep a secret. He spilled it out. Awesome. Yep, I love the activity. So this is a good exercise, I feel, because it gets us really familiar with the annotation process itself, but also the labels. And next week, when we look at a larger data set, we'll have a better idea of how the different annotators label this data set. Cool. I didn't feel the laughter level much. I was preoccupied, pausing and playing. But yeah, thanks everyone for pitching in there. Maybe next time we do this, we can do this as well. Or if you remember the laughter level, increase the number now.
That was great, George. Thanks for setting that up. That must have been a lot of work.
Yeah.
The clip and the dialogue and everything.
So
I agree with that. That was impressive.
Yeah, the entire corpus is available online. It's open. The dream team would be to do this for a larger data set, but then again, that's the most labor-intense process we can do. I just picked a very small snippet and a very small episode for us to get an idea of how this looks like, and also next week when we challenge ourselves with a larger data set. The other thing I wanted to share with us as a group is, well, we use a simple spreadsheet here, but what other tools are there that can help us with this annotation process? And one of them is this open source tool called Docano, and I'll just quickly go over it. It's basically text annotation for human. It can help us classify documents, let's say sentiment, let's say positive or negative. It can do part of speech stacking, more traditional NLP tasks, and name entity recognition as well. Or you can even do sequence to sequence. You can translate, let's say, a sequence from English to French, or from French to English, or from one language to another, or other cool examples. Like one that I have in mind is, there's a data set out there that has a question. And the question is, give me GDP for this country. And next to it, there's an SQL syntax. So the goal is to convert from English to SQL in using a deep learning approach, so that you can basically build a model that takes English as input and produces SQL as an output. That's a sequence to sequence example. There's a demo here of this annotation tool, just to give you an idea of how it looks like. Sorry, let me move this around. So this is the, if you look under live demo, let me minimize this. This is let's go under sentiment analysis. So you have a corpus. Let's say for us, this would be a sentence from our TV show. And we would classify it as one of the 6 or 7 labels, the different emotions. And you can say here, you can have as many as you want. In this case, it just has positive or negative. You do this for the first, you do this for the second. I'm just randomly selecting some numbers here. You get the idea. And then in the end, you can look at all these labels and you can use that as your data set for your model. And the good thing about this, if you host it somewhere online, let's say on Google Cloud or AWS, we can share access as a group, and we can do this in a collaborative way. The other task that you can do is name entity recognition. So I can identify, or you can label person, location, organization, event, date, other. So this is just another example. The way you do it is you highlight a sentence. Let me go to the next one. Yeah, you highlight something and you select location, organization. In this case, it might be tricky. It's an organization and a location as well. President, person, United States.
Can you add new categories on the fly, or do you have to set up a configuration file first?
You have to set up a configuration file, yeah. You have to set up a configuration file. It's very easy to do so, though. And you can also do translation. So you have a sentence, let's say in English, and you're trying to translate it in French. You can manually translate it, or you can select one of the given ones. Let's say, yep, this is just translation, translation, translation. So for my example that I had before that I mentioned, let's say you want an English sentence as an input, and you want this SQL syntax as an output. You need basically like a developer to do that for you. And there's also a GitHub page for this tool. It's an open source project that we were looking at the live demo. Yeah, and there's some information here. You can spin it up on AWS or GCP or Azure.
You'll put these on the meetup page?
Yep, I have it. I have it here already. The other one that's very popular, and it's a little bit expensive tool though. It's Prodigy. This one has very good annotation.
What am I looking at?
Features, yeah, text classification. This one can even do images, so you can do bounding boxes, or you can do image classification. Images. Text classification, what does it belong to? Politics, sports, entertainment. Freeform, I guess translation. Yep, and I have a demo here. So this is name entity recognition, text classification. So you read a sentence and you're supposed to categorize it. Is adventure, comedy, drama? This looks more like IMDb or like what? Yeah, this looks like a movie category. Let's see what else is there. Part of speech, tagging, adverb noun, relations. What deal is the publicist for the slasher movie? And you're supposed to mention the relationships. Mickey and the Scorpions. Let's look at a few other ones. Oh, okay, image, perfect. So this looks like a binary classification. Oh, this actually you do region segmentation here. Okay, this is more like classification. What are you looking at? Fruit, vegetable, plate, bowl. And I think, yeah, you can draw
I
labels.
have that one.
Yeah, you can draw labels here. You can even do other weird ones or freeform. Audio, I haven't played with audio.
Look, on that stump. Is it a chipmunk? It looks like a chipmunk, all right.
So I guess you're supposed to say if it's a speaker, if it's an animal, if it's music.
Whoa. What just happened?
What happened? So it has a lot of features, basically. Let's look at another audio one.
Well, a squirrel like that's a waste of time, and Squeak has work to do.
So I guess you're supposed to listen. I'm not sure what the video, oh, this is video, so yeah. So you're supposed to listen and look at the video and tag which part of the video is about is mentioning a speaker, or is a speaker talking, or maybe there's an animal, or there's music playing. And you can edit these tags or this.
Can you have overlapping tags on any of this?
Yeah, I would imagine so, right? And some of them, there's a speaker and a music, or animal and music.
Can you highlight the?
Are you drawing boxes on them too?
Let's see. They only have one video example, so they have a play. They have a zoom in, zoom out. That's for the audio part.
So maybe they're only like temporal boxes.
Yeah, it looks like that. So you're only annotating the temporal part. I don't see any annotation on the video itself.
Because that would be an awfully labor-intensive process to annotate the pixels as they move around.
Yeah, this is an interesting challenge. I mean, you're labeling the audio, right? So I don't know how much. I'm sure the video would give you more information, but I don't know how to use that as an input apart from this labeled data set down here. I don't know. Or maybe you can use the label of the audio to actually classify the image. I don't know. Like, you know, that this audio here, but then again, this is more advanced example. Not sure. This is just features of the tool.
Look, on that stump.
Okay, so this is where you're actually giving the transcript, so you can do audio to text, basically. And, okay, text, single choice, multiple choice, healthy food. Oh, interesting. Okay, let's pick some here. And this might be subjective. Next. Healthy food, blueberries. I'm not sure what I'm looking at here. Potatoes, bagels. Why not? Roasted, why not? So I guess you're classifying food if it's healthy or not. That's what it looks to me.
It's a rather subjective classification.
Yes.
Eye of the beholder.
Does Then this, I'm not sure what this is. German to English, maybe? Diff. I'm not sure what this is. It's just the English or the German word and the English word next to each other. Okay.
Or maybe it's a difference between it's been doubly translated back into the original language, and maybe these are the words that it got wrong.
Yeah.
Differencing the two sentences back in English.
Yep, you think so? Oh, yeah. The summary was last updated on March 2019. I like how simple it is in German.
Like maybe the red means the word was removed. The green means the word was added. So maybe the original sentence was the red and the return is the green.
Yeah, yeah. Oh, no corrections here. Interesting. Let's look at the last one, custom HTML. Well, this is interesting. This one like structured data. What is the goal here? Business. I'm not sure what the goal is here. Okay, I'm sure in the documentation they have more examples, but maybe the goal here is to reconstruct this as input and label, like the price would be the label. I'm not sure. This reminds me of when you take a picture right of a receipt and you're trying to scan, you're trying to pull out the information from there, but that's like an image problem. This, I'm not sure what this is. Price catalog. Anyway, that's this tool here, Prodigy. And it has a very good UI and a very good API as well. Computer vision, audio and video, A/B testing, dependencies and relations, name entity recognition, text classification. Cool.
You said this wasn't free though?
No, this one, I think it has a free trial, but after that it gets pricey.
I threw it in chat, but I'd recommend Label Studio as well.
Okay.
Label Studio, it's yeah, free as far as I could tell.
Okay.
It lets you do image bounding boxes.
Okay, is it for image only? For computer
No,
vision?
it's for text as well.
Oh, text as well. Name entity recognition, bounding boxes, key points and landmarks, polygon labeling. Nice. Pairwise labeling. Oh, audio segmentation. Perfect. Transcript. Text classification. Okay, a lot of the features that we saw. Okay. Oh, it works with TensorFlow as well. Maybe we should check it out then. Okay, perfect. So audio, image, text, HTML, regions. Nice. Thank you. Thank you for sharing. I'll include it in our slides. Any other tools anyone uses or has heard of or can remember? I'm always curious. Could be any field, NLP or image or audio.
This is G. I'm going through some old email note exchange with colleagues from last year, but there is I don't know if I was late, so I wonder if you guys talked about these AI assisted labeling, meaning have AI ML labeler doing the first pass and just kind of give the kind of the human in the loop. Human just step in on these kind of cases where the AI algorithm is not sure, the confidence is low, and then you just kind of keep fine-tuning the AI model as you go. The AI ML assisted labeling. I will send out some links when I find. Apparently, there's some very awesome open source stuff for this sort of thing too.
Perfect. Thank you, G. That'd be cool. Yeah. No, I haven't used any of those tools. I've heard of them. I might have seen them online, but I haven't personally used them. And I love the approach of using some kind of a model first, AI first, to take a stab at it, and then for the difficult ones or the ones where the level of confidence is low, you have a human in the loop.
Right, and then as the human, keep in the loop, and then the AI gets more and more confident, so you need the human less and less.
Yep.
Yeah, I'll look it up and send you guys the links.
Perfect. Thank you.
Mm-hmm.
So that was, going back to our slides, that was step 2, where we labeled a very small data set. The tool that I mentioned, Docano tool, the annotator, as well as other ones that you mentioned, Richard. And yeah, the challenge or the invitation is, if you find this interesting, or if you find an interesting data set that is not out there and probably can benefit us or the community, maybe we can annotate it and use our different approaches to do some kind of classification or emotion detection. The main goal of this week was to actually prepare us for week 3. In week 3, we'll look at 2,000 dialogues and about 29K different sentences, and we'll detect emotions, one of the 6 or 7 emotions that we saw from another TV show, Friends. Cool. That's what I had for today. Thank you for joining. If you have any questions, let me know, and please make sure that you RSVP to our next Friday's session, which is a week from now, and I'll open it right here. And in here I have the information about the series, the EmotionX URL that I mentioned as well. There's a more advanced data set which adds another layer on top of the emotions. We don't have to explore that, but at least using this annotated data set here, it'd be cool to look at the speaker and the utterance, and the goal is to predict the emotion for this entire training data set. And there's a training, there's a validation, there's a test data set. So it's very well built, and there's about 64,000 rows here. So we have some data. Cool. Comments, feedback, questions? Thank you for sharing the tagging tools. I'll make sure I add them.
Very nice.
Is there something that you want us to work on for the next time, or is this just, you're going to kind of go over this next time?
Yeah, just get familiar with this data set. If you're pretty good at coding, give it a stab, give it a go. If you remember in our TensorFlow in practice, we did a sentiment analysis from tweets, from movie reviews. Sorry, we did classification for tweets, if it's sarcastic or not. This is just another application of that, but now it's multi-class. Instead of just yes or no, positive or negative, now we have to label or to detect one of 6 or 7 emotions, as we did here in our example.
Okay. I think it'd be great if people could, by Friday, try, if you have a chance, try out an approach and give us some feedback on how it worked for you.
Yeah.
And in Slack, our coding channel, we'll be pretty active on it, I'm sure.
Yeah, and again, if you're not part of our Slack channel, it's right here on today's session. I'll copy it on Zoom right now. I don't know, I found the last week's challenge really interesting. I thought it would be kind of easy. It turned out not to be that easy. So I find that fascinating. Like, okay, this is just image classification, but then, this model is performing well. This model is not performing well. Why? I just posted our Slack channel.
I thought challenge is easy or not is all relative, right? It's generally not too difficult to get a model functioning doing something.
Yeah.
I thought this was interesting. I liked seeing the tools that I'd never seen this before about how they're used, because sometimes I I don't know, sort of get stuck, in visualizing how to solve the problem, wondering like kind of how the data and the labels came about. And it also will help me just as we were going over them. I was thinking of how I might apply those tools to, labeling, to projects that I'm interested in, that I hadn't thought about before. So, this is different than just looking at coding.
Yeah. Yeah, the goal is to look if there's something out there that already does this for us. If not, then, we might tackle it. But if there's a tool that helps you with any annotation or any explanation or any data exploration, then yeah, we can use it. Like the approach that you mentioned, that you can have a model to basically help you with labeling, that's super useful because that's very labor intensive and very costly operation.
I was actually reading that, there are labeling companies, and that like the big AI companies, Google and all the rest, they don't do it themselves. They farm it out to companies that specialize in it.
Yeah, and if you look at the cost here, I think these annotators were giving like at max, $0.25 for just annotating one sentence. So I don't know.
Right.
Depending on their state of mind, how much they had that day to do.
Yeah, actually, at the AI trade shows, you often see booths of these labeling companies, and then there's always the Amazon Mechanical Turk, right? Those crowdsource. I think the average is like $10 an hour. If you think your time is worth more than that, then pay those people to do label for you.
In terms
someone,
of, go ahead.
Someone who's done labeling for months upon months, I think what she proposed is interesting. Like the whole, can you have a prediction on top to assist the labeling effort?
Mm-hmm.
And I don't know what's good at it. Like I've seen the figure 8 and the Mechanical Turk solution, but it's always curious to see what we can do to make the laborer's job easier.
Exactly, yeah.
They develop an unsupervised learning model that can do the labeling.
So we talked about the Machine Learning Paper Club.
Yeah, you want to speak a little bit about that, Robert? What did we talk about yesterday? Because it kind of ties up with that.
I certainly just trying to get a grasp of it here, but we're essentially studying the fixed match algorithm proposed by Google a bit ago for one-shot unsupervised learning, essentially trying to figure out from a bunch of unlabeled images, like which one is the one to label to maximize your performance overall.
I was making a joke.
Apparently Google thought of your joke before.
Yeah. Yeah, this was an interesting paper where you use your unlabeled data. And it kind of reminds me of what you were saying, David, where in the Cassava dataset you had, for the Kaggle dataset, you had labeled training dataset, but then you had 2 extra folders, which was unlabeled.
Yeah.
And we didn't know really what to do with them, but then you mentioned, hey, maybe you can just use your base model to classify them and use that labeled data set, mix it back with the training set, and then increase your training data set.
Yeah.
So this is kind of what this paper was proposing, and at a very high level. It was using unlabeled examples, and it was using the model to distort, augment a little bit the image, and then use the highest or the most confident class and use that as a label, then protrude or distort even further the image, and then try to build a model that even for this highly distorted version of the image can still pick up that label. There's 2 follow-up meetups, one from Bethesda and one from Machine Learning Paper Club. We'll have a guest speaker from Leslie. He'll talk about his proposed version as a better version of this fixed match algorithm. Cool. I don't want to go too far here. Thanks again for joining. I hope you enjoyed this live and interactive session. And I look forward to seeing you next week, where we'll actually be looking at some models. I strongly encourage you to look at some code and try and tackling this. You can use some of the code that we used a couple of months ago when we build our NLP models. And hopefully by next Friday, the goal is to have some code and some accuracy metrics to talk about.
Thank you very much.
Cool.
Thank you, John.
Thank you for joining. Thank you for coming.
Thank you.
Thanks, everybody.
Good night, everyone.
Thanks, George.
Thank you, George.
Thank you. Have a good weekend.
Yeah, you too.